That hands-on machine learning exam, it can feel pretty intimidating, right? You're sitting there staring at a blank notebook, the clock's ticking away, and you're trying to pull hundreds of lines of code out of thin air. But what if I told you the real key to passing isn't about memorizing everything? What if it's about having a simple, repeatable template that you can adapt to any problem they throw at you? Well, in this explainer, that's exactly what we're going to build together. And that's really the core promise here. Forget trying to memorize every single function. We're going to give you a rock-solid workflow that you can lean on every single time. We're going to focus on understanding the flow, not just the code. Okay, first things first. Before you even think about writing a single line of Python, you have to get your environment set up. This is what I call step 0. And trust me, this is where you will pick up some of the easiest marks on the entire exam. So whatever you do, do not skip this part. Your setup has just 3 simple parts. You're going to create an S3 bucket to hold all your data, a SageMaker instance to do all the work, and an IAM role that lets them talk to each other. Let's just quickly break down what each of these actually does. Think of the S3 bucket as your digital filing cabinet. It's where you'll put the data set they give you in the exam, like cars.csv or something. And it's also where you'll save your final prediction file if the problem asks for it. Super simple, super straightforward. Next up is the SageMaker notebook. This is your lab. It's your command center. It's the environment where you'll fire up a Jupyter notebook and write every single bit of your machine learning code. This is where all the magic is going to happen. And finally, the IAM role. You can think of this as the security keycard. It gives your SageMaker notebook the permission it needs to go into your S3 bucket and grab the data. Without this role, your notebook and your data can't talk to each other. It's as simple as that. All right, so our cloud services are set up, and we've got those easy marks in the bag. Now we can move on to the main event, the ML code itself. We're going to build this thing out piece by piece, like we're assembling a machine, following a really clear, logical sequence. Every single project starts right here. Step 1 is just importing your tools, pandas for handling the data, NumPy for any math, and of course, the key modules from scikit-learn for the actual modeling. Once your tools are loaded, step 2 is a piece of cake. Just use pandas to read your dataset right from that S3 path. These 2 steps are your absolute, non-negotiable starting block. Okay, next, we get into probably the most critical part of the whole process, data preparation. Step 3 is where you'll clean up all that raw data, and we'll dig into the why of that in just a second. Then, after it's clean, step 4 is about defining your goal. You split the data into X, which are all the features the model will learn from, and Y, the one thing it's trying to predict. So let's quickly talk about the logic behind that cleaning code. You drop missing values because, well, most models just can't handle them. You might create new features, like turning a year column into car_age to give the model better information. You log transform skewed data to help the model learn the patterns better, and you drop columns that are just useless noise. See, it's not random. It's all about improving the quality of your data. Okay, this next part is a total lifesaver. You literally just make 2 lists, one with the names of your numerical columns, and one for your categorical columns. Then you plug them into this amazing tool called a column transformer. This thing is brilliant. It automatically applies the right preprocessing to the right columns. It'll scale your numbers and one-hot encode your categories, all without you having to do it manually. This prevents so many common mistakes. And now we bring it all together. We take that preprocessor we just built and we bundle it together with our actual model. In this case, it's a random forest regressor, into one single elegant pipeline. This is so important because it guarantees that your data is always pre-processed in the exact same way for both training and testing. And this really shows you the concept perfectly. Data goes into one end of the pipeline. Part 1, the preprocessor, gets it all clean and formatted. Then that clean data automatically gets fed into part 2, the regressor, which then makes the predictions. It's a seamless 2-step assembly line for your data. We've built our machine. Now it's time to turn it on, find its best possible settings, and then, most importantly, prove that it actually works by evaluating its performance. So, you're going to see this big block of code for something called Grid Search CV. Don't let it intimidate you. All it's doing is automatically testing a bunch of different combinations of model settings for you. It might try a model with 100 trees, then 200 trees, then a depth of 5, then a depth of 10, and after trying them all, it just tells you which combination worked the best.
It's like your own personal automated model optimizer.
After all that work, how do you actually know if you succeeded? You really only need to focus on these two metrics. The R-squared score basically tells you how well your model is explaining things. The closer to 1, the better. And RMSE, that just tells you, on average, how far off your predictions are. For that one, lower is better. Just print these two numbers, and you are golden. Now, listen up, because this is absolutely critical, and it's a step so many people forget. Remember way back in the cleaning step when we log transformed our target variable? Well, you must reverse that transformation on both your predictions and your actual test values before you calculate those final metrics. You use np.xpm1 to do it. If you forget this, you'll be comparing logged predictions to real values, and your error metrics will be completely wrong. So, we have walked through the entire template, from setting up the services to evaluating the final model. Now let's just zoom out for a second and talk about the mindset you need to walk into that exam room with. Here it is. This is your entire strategy on a single slide. Know the sequence of steps, apply this template. The only thing you'll really have to change from problem to problem is which column names go into your numerical and categorical lists. That's it. After that, just print your metrics and save the results file if the question asks for it. That's the whole game plan. And I want you to remember this philosophy. The other parts of the exam, the analytics parts, that's where you can really score big points. This machine learning template, this is your insurance policy. It gives you the confidence, the surety that you have a solid working model and a guaranteed pass on this section. Seriously, you don't need to have every line memorized. You just need to understand the flow and know how to adapt this template. Go into that exam with confidence, all the very best, you got this.